Welcome to aminacademy.com. In physics, regarding waves, let us do some solving problems. Look at this example. A string of mass 2.5 kg is under the tension of 200 Newton. The length of the stretched string is 20 meter. If the transverse jerk is struck at one end of the string, how long does the disturbance take to reach the other end? That means here the time taken is asked to the jerk reach from one place to one end to other end. Here the given thing is tension E equal 200 Newton. Length of the string, stretch length of the string is 20 meter. Mass M equal 2.5 kg. Then mass per unit length of the string, mass per unit length is mass is 2.5 over length is 20, which gives 0.125 kg per meter. Now wave velocity for this formula, wave velocity V equal square root of T by mu. Mu means mass per unit length of the string, which is equal 200 over 125 the square root, which is equal 40 meter per second. Now the time taken to reach the jerk reach from one end to other end, that is T equal time taken to reach, that is L over velocity. Distance by velocity is the time. Distance is 20 meter. The time is 40, which gives 0.5 second. That means in 0.5 seconds, the jerk reach from one end to other end of the string over 20 meter. Next question. A bat emits ultrasonic sound of frequency 1000 kilohertz in air. If the sound meets a water surface, what is the wavelength? That is A, the reflected sound, the transmitted sound. Speed of the sound in air is 240 meter per second and in water is 1486 meter per second. Here, that velocity, the frequency is given. Frequency is 1000 into 10 power kilohertz, that is 10 power 3, which is equal 10 power 6 hertz frequency. Then velocity of sound in air VA equal 340 meter per second and velocity of sound in water equal 1486 meter per second. Wavelength of reflected sound. Wavelength of reflected sound equal, now we know that velocity equal to f lambda, we need wavelength lambda equal to v over f. V is velocity of the sound in the air is 340 given over frequency is 10 power 6, which gives 3.4 into 10 raised to minus 4 meter. This is the lambda wavelength of the signal given by that. Wavelength of the transmitted, this is a wavelength of reflected wave sound, then wavelength of transmitted wave through water. Transmitted wave is same v equal to f lambda, and that lambda equal to v water over frequency. V water is 1000, velocity of water is 1486 over frequency is 10 power 6, which gives the value 1.486 into 10 power minus 3 meter. That is lambda is this one. Now we calculated that wavelength of the signal, reflected signal from the water surface and through transmitted through the water surface. Both we got it. We can write here lambda water, lambda air. One more question. A transverse harmonic wave on a string is described by y of xt equal 3 sine 36t plus 0.018x plus pi by 4, where x and y are in centimeters and t is in second. The positive direction of x is from left to right. First question, is this traveling wave or a stationary wave? First, the given equation is y of xt is 3.0 sine 36 plus 0.018x plus pi by 4, where x and y are in centimeters and time is in second. First answer. The question is this traveling wave or a stationary wave? If it's traveling, what is the speed and direction of its propagation? Here, the equation is given of traveling, is a traveling wave. It's a traveling wave. They're traveling from right to left. That is along minus direction. Along minus direction. From right to left it travels. Direction of x because it is an equation of the type, because it is the equation of type traveling wave equation A equal equation of the type y of xt equal y of xt equal A sine in general form, A sine omega t plus kx plus phi. And that here A equal this amplitude, A equal 3 centimeter, then omega, comparing this, omega equal 36 radian per second, 36 radian per second, and k equal 0.018, 0.018 centimeter, and phi phase angle is pi by 4. That means we compare this equation and the given equation. So therefore, speed of wave propagation, speed of wave propagation is, that is v equal omega over k, that is 36 radian per second over k is 0.018, which gives that is 36 radian per second here, radian per second, and that is 0.018 into 10⁻⁻², because we convert in meter. So radian per second, then meter per second, which gives velocity is 20 meter per second. Therefore, we got it. What is the amplitude? Amplitude is first one is it is traveling wave or stationary wave. It's a traveling wave. If it is traveling, what are the speed of and direction of its propagation? The propagation is, speed of the propagation is 20 meter per second and negative direction. Then next one, amplitude. B, amplitude A equal 3 centimeter, which gives 0.03 meter. Then frequency of the wave. Frequency of the wave we have to find here. Look at here. Then what are its amplitude and frequency? Now frequency is omega by 2 pi. Omega equal 36 radian per second over 2 pi gives approximate 5.7. 5.7 hertz. Then amplitude is 3 meter and frequency is omega by 2 pi, that is 5.7 hertz. Then third is, what is the initial phase angle at the origin? See, initial phase angle at the origin, that is phi, is given as pi by 4. That is, this is an initial phase angle at origin. Then D, what is the least distance between two successive crests in the wave. Here, least distance between the two successive crests. That is, they are asking wavelength lambda equal that length of the two successive crests is its lambda, that is wavelength, which is equal 2 pi by k. 2 pi over k is 0.018, which gives 349 centimeter, which is equal 3.49 meter. So far, they have done some problems on wave propagation, that is solving problem in waves we have done. Please subscribe our YouTube channel.